Hi everyone, I hope everyone is okay. And after the break, it's a totally different world, unimaginable. Anyway, we will pick up from where we stopped before the break. We were talking about threads and that's a bolt nuts. Today we're gonna take a look of bolt and nut design. I would say procedures. How do we design the bolt nut? Now let's say if you know the load. Okay, so let's design the bolt first. Let's say if you know the node, you know the node from load, and you can calculate the stress. And from stress, then you set the stress equal to proof strength. You set the stress equal to proof strength, then you can find out the from that one you can find out the AT, which is tension area. So this is tension area. So that's tension area. And from this tension area, there's a table in the book, and then you can find out both sides. I will give you example later on to follow this procedure to do an example here. But right now, we just need to take a look at this. Now, with both sides, now you find out both sides. And what we need to do is we need to find out, and then with both sides, we need to find out initial loading. And the initial loading, this is the force that we need to apply so that the bolt and nut is not going to get loose. And we use this formula here. The initial loading is equal to 0.9 AT times SP here. AT is the tension area. Now, this AT and this AT probably will not be the same, because once you find out both sides, this may not be exact the AT of this both sides. I'll explain this later on here. And then with a proof strength over there, you find out the initial loading here. So proof strength, initial loading. And from that, then you can find out the tightening torque. Okay, tightening torque. And T is equal to 0.2 FID. I'm not going to explain how do we come up with this formula. We're just going to use this formula here, and we're just going to practice how do we design the bolt and nut here. So you find out that. So in a problem that you know the load, how big a bolt you need to use, and that's how we do it. So first you calculate the stress because you know the load, and then the stress equal to proof strength, and then you will have tension area. From that you will have tension area because stress is equal to load divided by area, so you can find out the area. Now, once you know the area, you go check the table, you find out both sides. From the both sides, you can go back to find another area, tension area. that is slightly different from this value here. And you're going to use this value here. So you find out the initial loading, you find out the torque. That's what we need to do. We need to find out the torque, how much torque we need to tighten the bolt and tighten the bolt and nut. Now that's another question, is that because we designed the nut, use softer material, not really soft material, less strength material with less strength than bolt. So the question is that sometimes the stress in the nut is gonna get stripped, and we need to find out how big, how thick a nut, we need to use to prevent the stress being stripped. So that's the next question we need to answer. So we need to design the nut. The nut, so we need to prevent the stress to be stripped. So we have this formula, we use this one here. The shear stress on those stress on the nut, should be equal to both tension stress, not stress here, shear force on the nut should equal to both tension force. Should equal to both tension force. Okay, then we'll come up with a formula. Then we can find out how much is the thickness of the nut, so that those stress on the nut won't get stripped.